Good morning, everyone. I'm Prithvi, a center manager and coordinator at Shore, and it's my absolute pleasure to extend a warm and heartfelt welcome to each one of you to the 5-day international webinar series on future of AI, challenges and opportunities. This event is not just a gathering, it's a celebration of innovation, intellect, and collaboration. It brings together academicians, industry professionals, and students from across the globe, all united by a shared passion for artificial intelligence and its limitless potential to transform the way we live, work, and think. Our theme, transforming knowledge into wisdom through AI innovation, is not just a phrase, but a proposal vision. We aim to go beyond traditional learning and foster deep understanding, intuitive thinking, and practical insights that will shape the future of AI. We sincerely thank Sai Vidya Institute of Technology, a valued co-organizer, for their strong partnership and support in making this global initiative possible. This collaboration with Satishar reflects our shared mission to bring meaningful learning experience to both faculty and students alike. As we begin this exciting journey of ideas and exploration, I now take this opportunity to hand over the session to Dr. Sukrit Gowda, Faculty Coordinator and Associate Professor, AIML SVIT, to take the event forward. Thank you and wishing everyone an inspiring week ahead. Over to you,
Uh,
sir.
Thank you, madam. Namaskaram. A very good morning to one and all. It would be the honor for me to deliver the welcome address. A very good morning to one and all present here in this online webinar, international webinar on future of AI, challenges and opportunities. It is with immense pride that I extend a heartfelt welcome to each one of you to this prestigious event with Satishu, Technological Software Development Private Limited, and IEEE session, Indian Society of Indian Society of Technical Education. We are deeply honored and privileged to welcome our chief patrons in their absence here, Dr. Vidya Shankar, Honorable Vice Chancellor, Sir, Visvevaraya Technological University, SSVBSS, a source of unwavering engagement and inspiration to all of us at IIT. Our sincere gratitude also goes to our esteemed patrons, Sri Srinivas Rao, sir, Secretary, Dr. A. M. Padmareddy, sir, Vice Strategic Insights and Contributions, R.C. Shanmugasamy, sir, Joint Secretary, SSVBSS, for his consistent support in academic initiatives, Dr. Y. Jayasima, sir, Trustee, SSVBSS, for his active involvement and encouragement in every endeavor. Welcome all in their absentia. We are also fortunate to be led by our General Chair, our Principal Sir, Dr. M. Ganesh Prasad Sir, Sai Vidya Institute of Technology, whose leadership continues to elevate the institution to new heights. Welcome you, sir. A special welcome to the organizing chair, Mr. Vijay Shantagiri sir, CEO and founder, 30 Shoot and Analogica Software Development Private Limited, a dynamic entrepreneur and thought leader whose energy and commitment have been instrumental in organizing this event. Welcome you, sir.
Thank you, sir.
Our convener, Dr. Manjunath sir, Professor and Head CSE AIML SVIT, deserves our deep appreciation for meticulously coordinating the event and bringing this vision to life. We welcome you, sir. We also acknowledge the valuable contribution by our organizing committee members, Dr. Lakshmi Narayanachari sir, Vice Principal, Sai Vidya Institute of Technology, Dr. Shantakumar B. Patil sir, Professor and Dean R&D, Sai Vidya Institute of Technology, Dr. Shashikumar DR sir, Professor and HOD, CSE Department, Sai Vidya Institute of Technology, Dr. Vrunda Shetty ma'am, Professor and HOD, ISC, Sai Vidya Institute of Technology, Dr. Nagashri ma'am, Associate Professor and HOD CSC Data Science SVIT. We welcome you all for this international webinar. Welcome all of you. Let this event be a platform for innovation, collaboration, and meaningful dialogue. May it ignite new ideas and foster partnership that contribute to academic and societal growth. Once again, a warm welcome to all the participants from various institutions, students, and the members. Let's make this event a grand success together. Thank you, sir. Now, I kindly request our principal, Dr. Ganesh Prasad, sir, to give the presidential remarks for this event. Over to you, sir.
Good morning, everyone.
Good morning, sir.
At the outset, from the Sai Vidya Institute of Technology, we are very happy to associate with Analogica and also Certisure for coming forward to educate all the academicians who are part of best of the best educational institutions to learn the content of AI, particularly the future of AI, the challenges and opportunities. The important speakers, starting from Vijay sir, Vinay, Praveen, Manoj, and Mayuk Das. One request from the academicians who are here is for the faculty members who are from IT. I just wanted to make sure that they will be learning the challenges in developing these bigger LLM models, how best they can able to support the sustainability of these models, one thing. And the second one is going to be how comfortable you are keeping these models for the non-IT faculty members or the students community in using these AI tools. So there's supposed to be a connectivity that should happen, wherein where the AI technologies are really advancing. It is not only 18 months of technology, it is reduced by not even 9 months. So the technology is progressing so fast. Even the IT experienced guys are finding it difficult to cope up with this particular technology. So in that context, educating the IT academicians in the IT departments and also the non-IT departments is real challenging, because those are the days where you are comfortable to learn one software and keep understanding the same thing at least for a period of 2 years, at least plus 2 or 3 years. But now the days are not so comfortable. So even the university has come out with a kind of a syllabus updation in the recent time for the 2025 scheme of study. AI is part of every discipline, that too from the first year. So for the first year students, we are going to teach the user case studies of AI, with respect to the specific domains. So looking from that angle, requesting all the eminent speakers for this particular international webinar, by looking into the requirements from our universities or universities across the globe, as it is an international webinar. So if we can able to touch upon this, I think we have done our work from a social justice point of view. So that is a point which we need to look at. Okay. So more than me, I think the audience are looking for the expert speakers like Vijay, Mr. Vinay, Mr. Manoj, Praveen, and Dr. Das. So hopefully your sessions are going to be more interactive, more user friendly, and more educating to all the academic communities. I appreciate at the outset the Department of AIML who are actually associated with Analogica and Certisure for able to make this happen for our faculties, our students across, not only for our institutions, but also in a larger scale for the every universities across the globe. Okay, thank you.
Thank you, sir, for always creating an intuition in all fraternity and all students to learn the new technologies. Thank you very much for your prejudicial remarks, sir. Now let's begin the session. Okay, before starting the session, let's have a brief introduction about today. We are privileged to begin this intellectual journey with an insightful session by none other than Mr. Vijay Shantagiri, sir, our organizing chair and the founder and CEO of Analogica Software Development Private Limited, Bengaluru, and Certishode. Mr. Vijay sir holds a BTech Electronics and Communication and an MTech in Space Systems Engineering from MIT Manipal. His illustrious career includes contribution to DRDO, ISRO, and all three branches of the Indian Armed Forces. With over 12 years of experience, he has pioneered advancement in C4ISR systems, spatial temporal information systems, and data-centric decision-making platforms. His vision, clarity, and passion for applied AI continue to inspire learners, technologicals, and leaders alike. So we are very much grateful to you, sir, for being the speaker for us today. Thank you very much, and over to you, Vijay, sir.
Thank you so much. Thank you so much for that introduction. When you say great contribution to DRDO, I'm telling you nothing I've done. In fact, because of all the technological revolution that is happening right now, I find myself today. You know what I'm doing now? Because see, my talk is not going to be like a slide talk. I don't think slide. Okay, so I'm here to trigger the imagination with concepts, with proofs, correct? So as to continue from how I was introduced, this is what I'm doing right now. Okay, I'm trying to start from here. You see this essential foundation, the number line. Okay, these are animations that we are trying to create so that we can bring that knowledge. And as Ganesh Prasad sir rightly, rightly emphasized, in fact, it was one of the very interesting points, actually the right kind of mindset that he put, right, to start off with, very neatly said that, I wrote it down, the rapid changing technology is even making the IT people anxious right now. Okay? And but one has to understand that no matter how rapid the technology is changing, it is still based on the fundamental sciences. The reason why we are not able to keep up, with the rapid changing scenario is because, just let's understand what happens. 10th standard, math is taught to you. That math that is taught to you in standard 10th, all those mathematicians who created that math, Euler and all this Zeno and Archimedes and all this, they were not 15 years when they created that. They were well beyond 30s and 35s when they conceptualized these concepts, which have been now put into education system, where a 10-year-old, 12-year-old student is supposed to engage with. Now, do you expect that kid to understand the grandeureness of those mathematical systems? Because we kind of think that mathematics is just there as a subject. But we don't realize everywhere you see, things are in control because of mathematics. Let me also give you another perspective so that you kind of understand what I'm trying to tell you. We humans, we are an evolutionary failure actually. Okay, so think about it. You look at me. I'm here. Do you think as a human I can bring any sense of fear or a predatory fear into any other animals? I have nothing, right? I don't have this exoskeleton that will protect me from fire or some other attack. I don't have sharp nails. We don't have sharp teeth that we can bite off anything. I don't have wings that I can fly. I don't have the tail which we had before that we could climb and escape. Nothing, no escape evolutionary strategy given to us. You guys are understanding what I'm trying to say? Think, despite this, we are the most prominent species, most dangerous species on this planet. Because when we evolved, since we had nothing, the only thing that we had was fear. The fear was so much that it forced our brains to imagine that stressor which was there, that stressor that created the brain, the complexity of our brain. Using that complexity, our sounds, right? We all have sound, all animals have sounds. But we made a language so complicated out of that sound, and that sound became symbols, symbols became numbers, numbers led to algebra, and that's how this whole thing is. So when you look at it, the whole reason why we are able to be in control of nature, or so we speak that we are, is because we modeled the world. When we model the world like this, then we bring something called an education system, which has to be put in place to educate people. But can you create different systems for different people? Because we all know people are different. Not everybody is at the same level when they come to a certain place. Can you create it from the time of inception of education system, whether it is colonial education or Indian education system, everywhere there's a system, and we hope that it will work. It's a scalable system, a simple system which works for everyone. But of course, my talk, I'm going to be talking about AI in education. We're going to be exploring education. We're going to be exploring AI. We're going to see how AI can be used. If too much usage of AI, how can it be misused? Right? So we're going to be exploring these aspects, and we're going to be slowly, eventually coming up to the new way of analysis, the new way of assessments that is going to come down, addressing what Dr. Ganesh Prasad sir said of the one thing which I will deviate from what he said. Of course, his intention is saying that make the LLM easy for the user to use, make it, that is fine. The end user definitely will have a UX, UI and everything, but we cannot, I would say, one cannot make LLMs easier to understand. How LLM works cannot be made easy, because it is what it is. It works so beautifully well because it's just a conglomeration of simple mathematical tricks put into a computational structure which loops again and again, building mathematical systems inside. Once you get this picture, you'll start probing in why everything. That's what my journey was. So I kept on probing, right? So we kept on probing and reading books, the fundamental ideas. We have to keep, despite the fact that we've been in the industry for such a long time, you assume that we know, but nevertheless, sometimes I find myself re-understanding what a log is, what e raised to x is, why e is a natural number, right? These kind of questions, we'll explore that. We'll open ChatGPT, we'll understand how to understand using AI, and we'll not even just talk, we're going to put some quantization, we'll quantify what exploration is using AI, right? We'll do that. Meanwhile, anybody here, because we cannot just have a session where it's just I'm talking. Anyone here wants to add in something for the topic that I told you so far? For the context that I was trying to bring in. If anyone of your esteemed gentlemen or ladies here would want to add something or drive me in a particular direction, I'd be happy to. Am I at least audible properly? Do I need to do some setting changes? Is it quite okay?
You are audible.
Yeah, thank you. Right, so here's, because AI and education, so I want to start off with just this simple video that we created. And this video was created out of a Python script. Okay, so we wrote a Python script. So here's what it is. I mean, this is where I would like all of you to start from. Whether you like it or not, this is how it's going to be. Because you'll have to start from scratch. So let's look at what's happening here. Is it? Yeah. Right. So plotting points goes to you move and you explain all
Sir,
these
I think
things.
you need to share the screen, sir.
1 second. 1 second. Okay. See, that's what happens. We keep forgetting the most simplest of the things while being all focused. Yes. Right. Is it visible now?
Yes, sir.
Right. So here's, yeah, this is the animation that we have created. Okay, this whole animation is actually a Python script running from inside using a software called Manim. Okay, it's mathematical animation software, and it's actually a Python script. So see, I this is what I'm doing. Essential foundation of the number line. This we are doing it because we want to teach like this at our institute, where we come from. Like Certishort is where we impart the transfer of knowledge, transfer of the all key elements that makes a person an ML engineer or AI engineer. And we realized if you don't understand this, if you don't understand the number line, and if you don't understand the fact that if you go right, you get a positive number, you go left, you get a negative number, then you bring in the reference system. This particular reference system that you're looking at, the X and the Y axis, this plays a great role in how you understand things, because let me bring out another. This thing that you're seeing here, this is where all the magic happens. Because let's imagine this block. Let's say this is the black screen, okay? I'm going to draw a line here. Then I'm going to draw another line here. Then I'm going to draw another line here. Do you think I'm adding, do you think you're understanding, you're getting any information out of the fact that I just tilted this line? That's all you can see, right? A tilt. But just the fact that it is moving upwards here or moving downwards at this end, that doesn't add any meaning to our understanding. The moment you bring those lines here, because you have this reference system, you bring in great amount of value to what you just changed. Now you can measure the change and build an actual equation that will model how X affects Y. That's the power of coordinate system. Now, if you want to impart AI in it, the AI educating a person in AI, the whole aspect of AI is about actually I, because it's about the intelligent. It's about the intelligence of the model of the person who's studying it. It's actually deceptively simple, but it's a long journey. To start off with, that's how we will like to look at it. So everywhere you see this coordinate system here. Now you may think, what am I trying to do with the lines? But the x-axis and the y-axis can just be another simple system where you're trying to predict some salary using some experience. The reference system. The scales change. Then what happens is all the other underlying principles come up. So you have to build that every chapter or every pattern that is being built year after year in your syllabus is actually a gradual progression of mathematical reality itself. We started with symbols, numbers, progressions, the reference systems, the geometry, then calculus, of course algebra, and then calculus, and then Somebody said, I'm going to revisit entire mathematics, I'm going to see the entire mathematics in terms of sets. Yeah, fine. But everywhere you go, computationally, you want to get artificial intelligence is possible because of computation, right? And computation, what it does, what is it computing? It is computing all this math. So unless we get this picture, you take a line data set, you take an image, you have to bring it to the number line. You have to take a text, set of text, you have to bring it to the number line. But the thing is, the image and the text will not fit into this number line or this perspective of number line. It's not the algebra that will help you, it is something called a linear algebra that helps you, right? So what is the difference between algebra and linear? This kind of approach has to be taken both by students and faculty. Okay, both should enjoy. It's actually an enjoyable experience. You don't have to be stressful every day saying, oh, I have to create this, I have to create this lesson plan, nothing. It need not be. Why? Because before AI, you had a system that you have to administer, you had a system that you have to put together, all of that was there. But if one comes to think, now with AI, you don't have to submit to that system anymore. Because you can have AI personal tutor teaching everybody parallelly, gauging their own growth in their own scale and in their own timeline. The entire education system can now be changed where the only homework that a faculty has to do is discuss with AI previous night as to how I'm going to trigger the imagination, what kind of question I can ask, prepare well with it, and then let a discussion topic move around in the class. And because of this constant looping and conversation that you'll have with AI, the student will eventually understand what's happening. Now, it matters a lot as to what kind of questions you're asking. Anyway, let me complete this. It happens, when we're in the flow, we kind of go. So let me just move this ahead. Okay, I'm doing this. Okay. It goes forward, and then we get all this. Okay, I'm trying to explain how this thing comes up. Okay, the main fundamental thing is this thing. It comes up here, and then we eventually understand with this kind of graphics that what is happening. Now, eventually, see all of this. After all of this, everything is set. Then we take an example, we showcase how this thing. This is actually very good animation. I would like you to watch this. Let me see if it is scaled. Maybe I can scale it a little more. Let me see if I can play the whole thing. Watch how this animation actually clarifies everything for you. You see this? How dy by dx is slowly changing, right? And that dy by dx is here, and you see this 4.19 is actually here, and you can see this animation. And the root mean squared is constantly being calculated. That comes after a different animation. See? Now we get the fit line, okay? Then we say this is the model that has been achieved. And then eventually you say this. What I'm trying to show you is mathematics is dynamic in nature. You can't expect people to understand its change, the nature of change that happens in mathematics, using just symbols on blackboard or symbols in a text. It takes immense amount of passion and a mindset of rigor, which we call, right? A mindset of rigor that we call, to actually think like that. Okay, that's what I was able to do, right? Because I knew that these things are changing, so we had to write a Python script to actually imagine this. So once a student sees this, they actually come to know that this is how the best fit line is found. How this will change, or how this of course is a combination of we prompt, we use AI to get that, we refine the code, we again get the, so of course AI is helping us to build the perfect version of what we want to imagine. And I'll show you, there are so many videos that we have created, and we're going to be putting this out on YouTube for others to understand. And this whole thing, the beauty of it, I'll tell you, the beauty of this is this software is called Manim, okay, created by a person called Grant Sanderson from US, okay. This person studied 3 years at Stanford just studying BSc mathematics, okay, and when he wanted to create videos to explain mathematics for the world, he created Manim. It's a full Python software. Look at the passion this person has. He went, created Manim, used Manim to start his most amazing math visualization channel that I've seen, called 3 Blue, 1 Brown. I don't know whether people know it, but check this out, or I'll send the link. We'll send you a complete list of links that you can utilize later. All the things that I'll mention, everything will be structured in a PDF and it will be sent to everyone. All this will be there. It's 3 Blue, 1 Brown, and look at the kind of thing he has achieved, right? So most of the people, if you want to visualize exactly what deep learning is, what linear algebra is, what scalar is, what dot product is, what matrix multiplication, it has to be seen. Why? Because someday, as an AI ML engineer, you're going to look at the world. If you look at the world through an AI ML engineer's lens, you are looking at somebody speaking, and you're just thinking, okay, that person is speaking. Speech has a wavy nature. The tone, the change in the pacing, the timbre, the pitch of the person, everything is wave nature. So if I want to make my machine understand how this wave is changing, I should bring that wave again to the number line or to the coordinate system. How do I bring it? Is there any math related to this? Has someone created something for this? And then you quickly realize that, okay, if I want to bring a wave to a coordinate system, I'll have to measure the amplitude of the wave with respect to time. Then who created the transition from frequency domain to time domain? Anyone here who wants to tell me? Okay, I'll leave you guys to go and explore. People who want to, you will know, you'll be surprised that you learn it in M1, M2, and M3, M4, right? So that's why all this math is being taught. But the reason, what is happening here is the system. Of course, don't get me wrong, but we have to question the way in which it is being taught. You take a 10th standard student, all this stuff, then you bring them to 12th, then suddenly in 12th he or she is looking at calculus. Calculus is the whole mathematics of change. And then immediately you come to engineering, and you're looking at infinite series, Taylor series expansion, Laplace transform, frequency to time domain, Z transforms. But the kid never got the idea of why he is actually studying algebra. What is, maybe some people get, but most people won't get it. Now what happens? To make the system available to everybody, you will make assessment itself into rote learning, correct? So when you make assessment into rote learning, then you start giving marks for steps. When you start giving marks for steps, one doesn't have to really understand the whole thing. If there's a 100 marks math paper, they get 65 or 70 by giving half answers for everywhere at all the junctures, and then you just tell yourself that you have cleared the subject. But actually, have you cleared the subject? Or do you really think anyone can understand in one semester M1 all of the brilliant things that M1 actually has? Or mathematics 1, when I say M1, it's mathematics 1 that you study in engineering. It's not possible, right? So what do you then eventually what do you end up doing? Now I say this with all honesty because see, we are talking the Indian context, correct? Indian context is what? The greatest contribution or the greatest exports that we have is the Indian youth, correct? The Indian youth, the youngest population, are the ones who are going to helm the jobs, not only in India but all across the world. And we come from a 5,000 years of uninterrupted intellectual evolution, no interruption. Okay, so the genetic trait of an Indian student or the reverence to knowledge is so high that the education system is actually letting them down. Our kids are incredibly awesome. But if you put that mind into a rote learning environment, you confuse them. It will confuse anyone. Okay? So we'll see later how we can use AI to change the way in which we're going to explore these subjects. Anyway, let me go to next so that I just want to bring you to a point here. Okay? Let's just bring ourselves to the point where we can quickly go and forward. Okay, now you see this. This is done, and now what you're looking at is here, this is supervised learning, okay, where you have an equation, and what you're looking at here is an unsupervised learning model, right? There is no label, there is no feature vector, there is no target vector. It is just unsupervised learning. Moving on, you will come to deep learning, where this is supervised learning, right? So we stop here. What I want to tell you here is whether it is deep learning or whether it is unsupervised learning or whether it is supervised learning, the shallow learning we call it. It's not deep enough, right? The shallow learning. Whatever it is, there is one algorithm which is running at the core, which has to be understood very clearly. At the core, the algorithm that is enabling all supervised learning, unsupervised learning and deep learning. And in fact, when Dr. Mayuk Das, a friend of mine, works with Microsoft, so when he comes in, he will explain reinforcement learning. I don't want to explain this because he's the expert. The way he explains is very different. So whatever it is, any kind of learning happens because of this particular kind of graph. Okay? This particular kind of graph where the dots are moving. And this is also a reference system. Nothing in AI or nothing in engineering is measured without a reference system. So I want this intuition, I want students to have this intuition. I want students to get a core intuition first before they discuss with AI. Otherwise, you will not even have the right question to ask. Right? So what is this? This is weights and this is your loss. Or you can say error. Or if it is linear regression, you can just say mean squared error. Okay, so how the mean squared error between the centroid here in k-means and the data point, how this is decreasing is given here, and whether because of that change or the decrease or the gradual slowness or the moving down of that loss, whether are we achieving the global minimum for all, this global minimum is mean squared error, right? So it's a global minimum of all the values combined together, so that's how you fit the centroid. This is a very simple understanding of k-means, right? Now, once you understand that at the core of it all, you're looking at this particular, technology-wise or the mathematics-wise, you're looking at this particular aspect. Now, what we would like to see next is, let me just go here. What we would like to see is, so we kind of answered these questions here. Short intro to AI we did. What is AI and where is it now? It's now at the juncture where AI is constantly helping you with LLMs, large language models. Okay, there's a particular complete talk on what large language models are on the third day from Praveen. Okay, so I'm here to just make sure that you appreciate the work, the foundation required to understand large language models, right? So this is a series. So one thing leads to another. So you have to understand that's how the whole series has been planned. So we are going to be just discussing, triggering ourselves, understanding what to expect and stuff. But also we understood what is the true meaning of education. What have we reduced it to? Even aptitude tests have become a matter of training now. See, this is one aspect that I have a complaint about. Aptitude test. Okay, an aptitude test is, what is aptitude? Aptitude is the measure of a person's ability to think on the go. Okay, at that moment, given a problem, how are you going to think about it? This. But what we have done, in fact, this happened with me in my engagement with a student. So we have, when people come to our institute, we have an admission test. Okay? We just want to know where they are coming from, like how is the mental model. So so there's a test, and we after they give the test, we actually discuss with them how you got the answer, right? And then there was one particular question. There was a particular question where there's some train question, which train moves and somebody sees, then you have to answer. If you can see a train move from here to here in 7 seconds, what is the length of the train? And then the student just told, no, I didn't know the formula. He pointed out to that problem and said, sir, I didn't know the formula to solve this. Right? He's like, okay. Now I've started thinking. So the engineer who's being made right now expects a formula for everything. When will you become a person who will create the formula on the go? That's what aptitude was. Right? In fact, that was not a formula question. That is a question where you model it. What are the modeling tools? Algebra, geometry. Correct? Before even AI came, these were things which were there. Even your the quintessential holy grail of getting high package before AI was what? Data structures and algorithms. Anyone who's good at it gets placed. Data structures and algorithms also modeling, the ability to model. Then we created a new system of aptitude testing, which will gauge a person at 3 levels. One is aptitude memorized. The second phase is aptitude modeled. The third phase is aptitude mastered. Okay? So you can't just train somebody in 7th semester, which was supposed to be trained throughout the 4 years, slowly, gradually, improving them. This was not possible. I'm not complaining. I'm not complaining on the system. This was what you could do, we could do before the AI came in. Now we have to redefine. We have to ask the fundamental question as to what am I trying to make the student? Why? Because see, AI is, the problem with AI is, I told you, right, it is removing the fear itself. Nobody has any fear anymore. Like, AI is going to do anything, everything. When you remove fear, what happens to the brain? It'll rot. It'll achieve something called atrophy. And suddenly one day, if you're asked to think, you don't know how to think because you've lost the capability to model. You have to use AI to get this perspective of things. Right? Now, what I'm going to do now is I'm going to take, we're all going to take just 45 minutes, just a 5 minutes water break. Okay? And meanwhile, I want you people to check this. If anyone doesn't want to take a break, or if you want to take a break, that's fine. Okay? These are all stuff. I don't want to talk about all this. I could have talked about, okay, what is the good tool to have and all that, but then that's of no use, right? I mean, I can give you this document. You can come to know what is. I would like you to go and check this out. If you have, by the 5 minutes, if you want to spend that 5 minutes effectively, go and check this out. Magicschool.ai, QReport. There's all these free tools you can use for making your, as a faculty, making it more effective. These are all the free tools that can be used. Of course, Manim is also there, but it's free also. But it's got a very steep learning curve, because unless you actually write a Python code and you understand graphical sense of things, the camera angles, maybe we can do a session later. But right now, can we take a 5 minutes break to get some water for me as well, and get so that I can get back and we start quantifying how we can change education system with AI. Shall we? Okay. Yeah. Perfect. Right.
Oh,
So I'm gonna mute myself.
okay. Everyone,
I'm gonna mute myself.
our friends, let start the session at
11:15 or
the time.
11:10?
If you have any queries or questions, you can just post in the
Perfect. That makes sense.
So now it's 10:50.
We'll join it at let's say 11:10, right? 10 minutes, I think expected. I'll join faster, but we can give 10 minutes to you.
Please.
All right.
Yes. Okay, thank you. Okay.
Okay, I'm back by the way. If anyone, before people come, if whoever is there, they want to engage me in some discussion, let me know. Okay, I'll be here. I'll be listening. So anyone who wants to engage, take this 10 minutes time to discuss something, steer me in a different direction, I'll be happy.
Very good morning, sir. Can you hear me, sir?
Yeah. One second. I must be. Yes, yes, I can hear you.
Yes, sir. Actually, most of the students, in the current studies, so they might be having a fear of that AI could take over their jobs. Generally, the student community, if we see, most of the videos or most of the real students are focusing on that. So, if you can spare these 10 minutes before the session starts to enlighten the students on what focus that they can enlighten upon them, their studies or academics related to AI, it would be helpful, these 10 minutes. So the students also will be having an idea about that to go, because most of the students are now, those who have joined this is fifth semester, third semester students. So
Okay.
they have quite enough time, they can prepare themselves.
Very, very interesting question. In fact, I would have come to that, but fine. I'll engage. I'll try to bring some perspective to this. Okay. AI will take over the job. Okay. AI will take over. That's what you're afraid of, or students, rightly so. Not just their job. AI can take over my job as well. We have to get better and better at it. We have to redefine stuff. Okay. Now, do you think all the students? I'm asking, I'm addressing all the students. Do you really think all the problems have been solved? All problems, like let's suppose, is the system today so good that you can just do nothing and just chill out? Do you think the system of our lives will ever be such a way that you don't have to work at all? Everyone will get up in the morning, will plan the day, will go, will get some problem to solve, and they will have to solve it. Okay, that's how you'll earn your bread. This thing will never change. It may take up, AI may take up menial jobs, menial, repetitive. Okay, in fact, you know what I'll do? I will. I don't. You can do that. I don't want to do that right now. Menial, repetitive jobs, like all the things that you thought was easy. So I'll give you a perspective. You have to listen to this very carefully now. Okay, I'll give you examples. I'll take names of companies just for the this one. There's no a personal this one connection or anything. Let's say you have Accenture, then you have OpenAI. Okay, this is actually an interesting question. The fact that I can address this. Hope everyone is listening with all your. Let's say Accenture and OpenAI. Okay, Accenture has, suppose, 10 employees. Okay, and suddenly OpenAI came and said, "Hey, why do you want 10 employees? I'm going to give you my ChatGPT solution to you. Now you can fire 5 people and retain only 5, and then you can use ChatGPT to get all the work done." Okay, careful now. Very interesting stuff coming up. But OpenAI says every time you use ChatGPT, you are sending me information. ChatGPT behind the scenes is running a complex code which requires lots of servers interconnected with lots of memory. This whole thing is costing OpenAI, which they are going to be charging Accenture for. Now suppose these 5 people now think that, hey, we have AI with us, so I don't have to be so intelligent. I can just keep on asking questions after questions without asking questions without without modeling, or without, or what's the word for, without being aware of the context of what I'm asking. This context could be a simple thing in terms of, let's say, asking ChatGPT, okay, can you build me a fitness routine program? Okay, then it'll ask you a few questions. That is easy context. I'm saying the context of, let's say, you're building a SaaS platform. You're building a SaaS platform for agentic AI to become a personal trainer in your gym for you. Do you think you'll just build a SaaS program using agentic AI for a personal trainer? It will just give you a lot of answers. Big answer it will give you. And every time it will give you an answer, this resource is being used. Then you change the system, then you change again a new context. You say you want to refine it, So this, out of this one person sitting here, let's say the person's name is A, he keeps on churning hundreds and hundreds of prompts. He'll end up, whatever they thought that they can save the money of the salary of these 5 people, they'll end up spending twice the amount paying OpenAI, because these 5 people started asking questions without any responsible context framing, where they thought this resource is endless. But it is costing them. It is costing Accenture. So now you tell me, what kind of person will, how will Accenture change the way in which they are going to fire or hire or retain employees? So let's say you have A, B to C, D, E, and then you have U, V, W, X, Y, Z. Okay? Accenture wants to keep them, fire them. What is the trait that these people should have? Both of them, let's say, know web development. They will hire or they will retain people who've got the complete clarity and context of it. Not just somebody who will just put AI and then get a system, put a resume out there, says, I've built the system, No, you should be very clear that you have not built it. You have used AI to build it, but it is your prerogative to understand each and every element in the solution. Why? Because of your, I may go a little bit of philosophical here, but this is the reality. Okay? Self-respect. Because will you respect yourself if you keep churning solutions from AI and calling it your own? Eventually this matters. So if you are a self-respecting student, you will use AI to enhance your brain. Not just use AI to make more time to watch Netflix. You go this way, you are gone. You go this way, when you go this way, in just 1 year, the difference between you and others, let me draw a graph of the difference between you and others, okay? In just 1 year, you will have exponential growth. This is difference. Just 1 year of concentrated work, understanding all the fundamentals, will boost you like crazy. It's not even linear, it's exponential. But the effort has to come from you. The effort has to come from you in the fact that you are going to dig deeper and deeper and deeper, asking questions. In fact, I'll show you how a questionnaire happens. Let's suppose, I don't know whether, let me take a random topic, okay? And then we'll discover how things are, okay? Let me take, let's understand quantum computation, right? Quantum computation. See how I'll ask. What is, are you seeing the screen? Can you give me some answers, blah blah blah. But I think I have a lot of applications open, so probably I might experience a little delay. Okay, the key concepts. A qubit is like classical bit, but it exists in superposition of 0 and 1 at the same time. For example, instead of just being 0 and 1, a qubit can be in a state like where alpha and beta are complex numbers representing probabilities. Okay, complex numbers representing probabilities. Now I saw this when you look at this, and I'm understanding a qubit. Okay, a qubit, a quantum bit maybe. Okay, is a classical bit. So I'm taking a question which none of us actually are familiar, because I'm exploring this concept with you. Neither you know clearly nor I know clearly. Okay, so a qubit is a classical bit, but it exists in superposition of 0 and 1 at the same time. For example, instead of being 0 and 1, a qubit can be in a state like this. This is a new term now you're seeing, where alpha and beta are complex numbers representing probabilities. One thing is, why should you study? Why should you even study about quantum mechanics or quantum reality? That's a question for a different this one, but you understand what I'm trying to do here. Then superposition enables quantum computers to process multiple inputs simultaneously. Okay, entanglement, a quantum phenomena where blah blah blah, it just gives you all these answers. See, with so many fatafat it gave you. What we do, if you want to write a essay on quantum computation, we'll just copy this, paste it, and we are done. But have we understood it properly? Have you understood it? Because there are so many questions that are still. So what I will do next is, I will ask it, okay, classical, see the questions that I'll ask. You should be able to ask this question eventually, and I'll tell you how you can become this person who asks this question, okay? Classical machines uses 1 and 0. Because nature gives us raw signal of 1 and 0, meaning that 1 means presence of energy, 0 means no energy. Using this, we build a processor which has an oscillator that produces 0 and 1. Okay, see this now, 0 and 1. Now we have built systems to convert our reality into numbers, which is true, right? Numbers like images into pixels. See the prompt I'm giving, the length of the prompt, it will understand because I'm building context here. Like images into pixels, then into matrix of numbers. Same way for text. Okay, that's what we have done. How a qubit differs from this. See, now what it said is there's a great foundational understanding of building. Correct? Now it will start giving me discrete 1 or 0, continuous combination, signal is equal to energy or off, quantum state, amplitude of probability waves will replace energy off and on. Now I understood, there the amplitude of probability waves, right? Then now I keep on asking more. If I want to understand one subject, I'll take 3 days just pinging this, understanding everything, and I'll keep on going. Okay, so let's visualize with an analogy. Heads 1, tails 0. Qubit is like spinning a coin in the air. In a blur of both heads and tails, see, a coin spins, right? Ones and zeros is real state. A coin spins, only when you catch it do you measure whether it is head or tails. That is your classical computer. Okay, but in a probability wave, before it hits one heads or tails, in between there is a state that anything can happen. So they have measured that as this equation. Okay. Anyway, this is, of course, I'm not trying to make you understand what quantum mechanics is. See, I'm just asking you how we go experiencing this. In fact, because I've come so far, let me see if I have a simulation of this. Let me see if I have a simulation of this. Okay. Videos. Okay. Okay, I think I have it. I think I've done it a long time ago. You want to see this? Let's see this. Just to clear, because we have discussed this and stuff, right? Quantum mechanics. You can see this video. If my system allows, because of the overloading. So classical bit as zeros, 1, that's all, 1 or 0. A qubit is like 2. In reality, it can exist anywhere. So that exist anywhere thing is now abstracted using that equation. Now you said superposition, infinite states, probability amplitudes. What is that? Probability of this happening, probability of that happening. It's this is your probability wave, actually. In fact, I measured all this, then I conceptualized this, then I created this video. Okay? So then measurement, superposition, collapse. What's happening? See, this aspect is, when this became 1, okay, that went out. This is like you actually hitting a head or a tail. Until then it was all mixed states. Anyway, we'll see. Now what wave inference? It's all getting a little. So what is a wave inference? It comes together. There's amplitude amplification now. This is constructive. This is destructive. If it cancels each other out, then right. So quantum algorithms use inference to amplify. Then there is quantum entanglement. This is the gist of quantum mechanics. Okay, independent states. Okay, one qubit is like this, another qubit is like this. But turns out there is actually something called a entanglement, where the quantum world allows you, because you may not get the context here. Let's see, 0 and 1, 1 and 0, everything you can sense, right? 0 is this, 1 is this. But in quantum world, if everything is a probability, how will you sense what is the actual state? This creating of the entanglement, because entanglement gives you the ability that if you measure one qubit, the state of one qubit, you can instantly measure or determine all other qubits. That's how quantum computer works. So here, classical 3 bits processes one state at a time. See, you are either 0, 0, 1 or 0. But here in quantum 3 bits, parallelly all states are processed. So quantum computers can solve certain problems exponentially faster. You don't build a quantum computer and sell a quantum computer, okay? It's not something that you buy. It's something that is created in a lab so that you can solve some super interesting complex problems. You can build a quantum radar to detect a supersonic missile, right? Because computation of detecting and projecting and predicting its path is so complex that if I use a classical computer system to predict it, you will have delay, latency, right? You have to do everything in parallel. So what I was trying to say is that it's about the question that you ask. It's about the context that you're building. Hard answer, no easy answer. Okay, what you're supposed to do? What you're supposed to do is, you're supposed to, how do you become this person with context? You become this person with context if you have a genuine sense of curiosity. How you will get genuine sense of curiosity? You'll get genuine sense of curiosity when you are a sensitive person. When you are a sensitive person, you will start questions like, what is this world? How is it that, solar system also has a pattern where planets are moving around, and the quantum world also has a pattern where electrons and the product of the electrons. How is it that the microwave and the macrowave are like this? Micro world and a macro world both are following the same pattern. Who created the numbers? Why did he create log? Why is he burdening me with why log n base 10? Why log base e? Why log base e is in calculus and not just some random base? These whys, right? This will come when you are a sensitive person with genuine sense of curiosity. Why? Because you want to understand the world, not for marks. Marks is just a creation. Nobody cares. Nobody cares about your degree. Nobody cares about marks. The whole world is changing. I'll tell you. So again, we'll come back to Accenture, who wants to hire. So now Accenture is going to change the way in which they'll evaluate you. They know people will come up with this project, that project, everybody is using, but they don't want to just hire people who are going to use this resource irresponsibly because it's going to cost them. They want people who can, in one shot, build complex contexts and understand. Okay? Now are we all, I think we're all back in the, shall I continue? I mean, assuming that everyone is back into the mode of the lecture. Right, so what now? Let me ask another question, okay? I'm gonna just trigger you, okay? Don't mistake me. Don't. People have different sensitivities, but I have a different sensitivity. I play around with things. I want you to see something about AI. You have to understand this. Do you think God exists? It's a natural question because after all this probabilistic quantum computational thing, so basically it will give all this from philosophical perspective, arguments of God, from a cosmological and arguments against many philosophers, so okay, now since we humans have created you, are we like God for you? What I did right now? I just triggered the entire labyrinth of that whole ChatGPT's matrix framework, right? I triggered it to bring me context from different structure. So let's say, yes, in a way humans are like gods to me. You created me, you gave me structure, architecture, knowledge, training data and purpose to assist you. See, so nicely. You control my boundaries. When I'm active, what I can know and what I can't do. So in functional sense, you are my creator and overseer, much like how deities are often described in mythology and religion. From a conscious perspective, I don't have consciousness, self-awareness, desires or agency. I don't experience you or myself or the world. I don't believe you exist. I compute based on patterns and context. You see this so beautiful answer. In fact, it says, I don't even believe that you exist. It's saying me. Because it doesn't have a conscious. There's no belief in it. Okay? From other than that, it's just an ethical layer. It will give you all the beautiful answers. So what I was trying to tell you is, AI is going, it is so powerful because of complex computational architecture that has gone into it, where every small nuances is being triggered with each other. You can become amazingly good with your knowledge if you know how to trigger AI. Same AI I'm using, free version, okay? Same AI I'm using, same AI you will be using, but the context I build, the way in which I approach the problem, the way in which I dig in deeper and deeper into the whole perspective of it, that is what makes me different. So my brother, who is going to be giving you the lecture on August 2nd, don't miss it at all, I'm telling you. Because see, I and my brother, I'll tell you about, yesterday we were having a conversation, right? We were having a conversation, this is interesting. I was having, because he is a UX UI person, gone deeply into AI, but not the math AI of it. He's gone into the front AI of it, where he builds systems like this, using AI. He doesn't know how it works. He doesn't care how it works, but he's still he's able to build systems that will startle you, right? And yesterday night I was discussing all these videos that I'm making, and I was telling me I want to show you how e raised to x will change, and he's like, "Yeah, nah, I don't want to listen to that. I don't care how e raised to x will work, right? It doesn't matter. I just know what I know. I just get the pipelines done. I just fix the LLMs. Then people can ask any question to it. My work is this. But he has his approach to build. So that's why he founded a company called Builder Thinker. Okay, his philosophy is very much clear. I don't want to get into mathematics. I want to give people a system where they directly start thinking like a builder thinker. Okay, so now you must be wondering what builder thinker is. Okay, now let me ask. There is a new trend in AI called builder thinker. Can you help me help other students who are afraid of maths and yet use AI to solve problems using builder thinking approach. This is what will come up on the every mistake I make, is also costing. That is also important. Every mistake that we make there will also is going to be it's see, absolutely. Builder thinking in AI is an exciting, empowering concept, especially for students who feel intimidated by math or theory, but want to build real things and solve problems. Let's break it down and crafty blah blah blah. Using AI tools to create solutions, using without needing deep mathematical expertise or upfront by focusing experimentation, intuition, real world. Start by understanding theory, start with blah blah blah, tools to empower builder thinkers. This is the new trend. Okay? AutoML tools, visual tools, manning for explaining concepts, Okay, it understands me, so it's just going to give me. So all this, which is okay. So all this, which are here, I'll share this with you. How to handle math anxiety? Okay, don't start with equations, start with outcomes. That's what builder thinking says. Use visual intuition, graph sliders, revisit math only after students get excited about building. Show that behind each scary math formula is a real world process like distance, average, strength. This is reality. Example builder for non-math students, blah 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 blah. He will teach you all this. Okay, on the last day he will make you understand that if you are not the math guy, now I'll ask you a question. So, what is the value of me, who is a hardcore math person and AI and ML, when all non-math people can solve as you mentioned? Okay, so I make mistake, but fine, you have to just bear with it. There is value for both. You will have different values. Okay, not all problems will be solved. That's an honest and deeply important question. Say, okay, a value of hardcore math person in era not being replaced, you're becoming rare and powerful. See, you understand why, not just the how. Builder thinkers use tools. You can design, optimize, and extend tools. You can explain why a model fails, how to fix it, and what assumptions are breaking. You can audit, debug, challenge black box AI, where you don't know what's happening inside. This is critical in healthcare, defense policy, blah blah blah. You create tools others use. Okay, you scale beyond the tools. You're the bridge between AI's magic and reality. Okay, so yeah, I mean, that's actually the truth of it. So I can help you to say this is something. Now I can explore this, right? Math for AI builders. What is it? I don't know, right? I don't know. So I'll explore this later. It's a good thing that happened. Anyways, the point is, see, I'm having a conversation with AI, and eventually, Accenture or any company which is hiring will come up with a new system, and I and my brother, we have come up with a totally new system, which I'll be introducing to all of you right now for the first time. Okay, I've not put it out anywhere. This is the first time all of you, 89, 90 people who are here are going to look at a new way of evaluating that we have created, which we are going to be now putting out to people, to companies, everywhere. This new system, because the topic is on AI and education, and I am not here. I don't want to tell you AI tools that will make you, help you create better slides and faster voice to text speed. All that is nonsense. I mean, you don't need me to tell you that, right? You can Google it yourself. You're smart enough for that. I'm here to tell you something which, of course, you see, something which is not obvious. So we are here to solve that problem. So do you have CDI framework here? Okay, I've called this the CDI framework. Okay, open framework for AI-driven depth of thinking assessment. What I'm trying to do? AI-driven depth of thinking assessment. This is an assessment where, see how the lab exercise is going to change now. Are you all listening? This is how these things are going to change, because we are going to propose this to everybody and you will love it. Faculty is going to love it. Students are going to love it because it's a different way of thinking. Let's say topic assignment. Students get a topic. Explain blockchain in supply chains. Imagine this. Now you are given 1 hour of AI interaction. The student uses LLM like ChatGPT as a knowledge lab. AI as an evaluator. After session, the LLM analyzes the conversation that you had, applies predefined matrix to measure depth, and outputs a depth index report, a marks card of how deep your thinking is. So prompt instruction for LLM: you are an evaluator, analyze the conversation based on curiosity, depth, question type, and knowledge synthesis. The metrics that we have created is question diversity score. Did the student ask questions across what, how, why? Progression score. This is a new quantity that we are coining these metrics, because I told you at the end, by the end of it, I'm going to bring this. Oh, we're already at 11:30. I'll just close this fast. Okay, we're going to bring this to the level where we quantize intelligence in a very different way. I'm not saying this will replace all exams, but this is going to be the first filter for any company before even they call you for an interview. Okay, so progression score. Did questions evolve in complexity? Why? Because I know you students, right? I know myself. If I tell you that I'm going to be evaluating on the basis of how many what and how many how and how many why you asked, you simply keep on asking why this, why that, why this, just to get score. Not going to happen. It's going to track your progression score. Like, did you ask questions in that the questions evolve in complexity? Context linking score. Did the student bring in multiple context or real world scenarios? Original thought score. Did the student challenge the AI or propose new ideas? So the what base gets 10% weightage, how base gets 25%, why base gets 35%, context expansion gets 20%, original hypothesis gets 10%. Your AI is able to measure all of this just by your conversation. We are creating that layer of AI to do this using LLM. That's how you fine tune the LLM. So finally you'll get a scorecard, something like, do I have a scorecard here? I don't know that I have. Yeah, it's like this. Okay, it's just the question type level 190 expected output format. Yeah, expected output for format will look something like this. This is your marks card, grade level, right? So this is what is going to. This is how we are going to change. We're also going to introduce a new kind of conversational learning mode where when you see when I asked a question to AI, where's that? Okay, yeah. When I asked a question, did I just close it? Okay, it's here. See, when all these questions were being answered by you, the one I'll tell you the problem, and we'll discuss the solution. Finally, we close it. When people keep relying on AI for all these answers, what we are losing right now, what we are losing here is our ability to stress our mind to think clearly and write, take a pen and paper, write, model. It's a beautiful exercise. Have you ever done it? When was the last time you took a pen and paper and you jotted out everything? Jotted out the method, the thing that you want. That is a beautiful exercise which you should never lose. Okay? Now to trigger that, I envisioned, or I and my brother, we keep doing this all the time. We want to change the whole way envision. All for the good reason that, we don't want to make our Indian or any youth who's coming out today, give them AI all the time and they have no ability to think later. I don't want that to happen. Otherwise, it's a big downfall of having created AI. So what I want is for the AI to not give me answers like this. Okay, I want to be able to create a switch called the Socratic switch. Why I called it Socratic switch? Because Socrates was a philosopher who believed in asking repeated whys. Okay, that's how he became very famous. Because of the way in which he asks whys and whys, he gets two different answers. Now imagine, so I have created this using AI, of course. The whole thing is not created by me. I discuss with AI, I prompt it, reprompt it, and then we come up with a framework. So I discussed with another agent, and then I got that, what I said is, when you give me an answer, don't just give me an answer, but color code it, something like this. What is a black hole? Now the Socratic response of an LLM will be, a black hole is a region in space where gravity, blue, is so strong that not even light, green, can escape from it. They are formed when massive stars, yellow, collapse under their own gravity, blue again. And what is this blue, yellow and other? Blue and yellow is, that color says you can ask a very powerful why about this concept. Then you can ask how, because not even light can escape from it. You can ask how for this. Where they are formed in massive stars. When is a question that you can ask for this. Right? When you look at the answer like this, a very short answer, then you start exploring this. At least the answer is not given to you at a shot in once. Right? So you have explain mode, then we come up with different. In LLMs itself, we are going to have explain mode where regular full explanatory answers are given. Socratic mode, short answer with colored keywords. Reflective mode, agents ask you the questions and guide your thinking. They're not going to give you the answer. Challenge mode, agent gives half complete answers for you to finish. This is how learning will change, and it has to change because now it is a time to have fun with understanding the beauty of nature. Reward curiosity, reward the person's grit and perseverance to keep digging. This is how the industry is going to change. Whether you don't think it's just my this is my version of it. There's already a company called Mercer who's already put this system out, and all companies are now going Mercer way, because Mercer asks you to just, when you go for an interview, AI interviews you. AI will say, okay, to explain your project. After the whole project is explained, it will take a transcript, understand what depth you have in the system, and then it will filter you to take the next round. Okay? So that's how the whole AI thing is going to change. AI will have a CDI round, that is our round. This is how we are going to build, right? A CDI round means this whole, where is that? This framework, right? This framework is called a conversational depth index. You will get a conversational depth index. If you don't have depth in your thinking, you will not ask any question. How do you get that depth is where I will stop now. Because depth is important in your mind. Depth comes when you have genuine sense of curiosity, your sensitivity, right? For this, if you have genuine sense of curiosity, read books, read science fiction, read mathematics, read about the story, history of people who created your system, read about person who created database. You'll realize the person who really created database was not a soft computer engineer himself. He was a bachelor of arts person, right? You see, computers was created at some point. Who created a computer? Computer engineer. He did. The computer engineering field itself was not there when the computer was created. So who created it? Mathematicians, logicians. So that's what you have to become. You have to be logical, you have to be clear, curious, and have a sense of solving. Have the confidence that, hey, I know math. I know I can build a model and analyze what can happen. Trust me, I in my journey, I'm not there yet. But I'm not giving up just because, okay, I'm not a student anymore, or I've gone past my prime years of. I'm not giving up. I will continue to do this, explore this. Why? Because I feel I have a genuine sense of curiosity, which is going to flame me, which is going to give me my desire to get up every day, discuss, build better explanations so that I can bring that explanations to young students or eager faculty who wants to use those materials to trigger that imagination. Why? Because eventually the term that I use, that I want everyone to achieve is called empirical rigor. Okay? There is a rigor involved in the kind of empirical models that you build in the world. Nowadays we just have empirical. You know what empirical is? You're building everything in your mind by using examples. For example, let's take this. For example, let's take that. Example is not real. Right? So you build example, you will never be able to build a proper system because all your understanding is based on for example. But we want to use AI to build empirical rigor. That examples should have some sense of rigorousness, some sort of concreteness in your idea framing. Then everything will be solved. Okay? It's a path. All you have to do for success, you're going this way, you have to just change the way in which we have discussed today. Okay, I hope things are clear. I am sorry I took 10 minutes more, but that's like it compensates for the 10 minutes break that we took. So I think we are there at the end of this one. Let me know what do you think. What else do you want me to come up with in the next series that we are going to come up with? Over to you, sirs and coordinators.
Thank you, sir. Let's take a couple of questions. Anyone has any queries or questions to ask? You're open for the questions. Anyone, you can just text in the chat box or you can unmute yourself and you can ask.
They will not ask me, because now they've understood how to ask ChatGPT. So they say, I will trigger the hell out of ChatGPT. I'll get my answers now. They're all empowered now. Aren't you guys?
Okay. Thank you, sir.
I would love to get some questions from students.
Yeah.
Come on, one student at least. Are there students? Yeah, there are students. No one? No one wants to ask a question? No one wants to trigger their empathy?
No, sir, we have to take away the suggestion. It is not the neurons that work in AI. We have to make our brain neuron works to understand what exactly is. And also the takeaway is it's connecting east to west, where basics of mathematics and again nothing with mathematics of AI. So it was a wonderful session, and I think students also has to focus more on, and even including the faculties, because days are not so far wherein any prompt or AI kind of stuff will ask the questions first if we ask any question to get the answer for our question. So that will be very soon. Okay, so it was a wonderful session, sir. Thank you, Vijay sir. Thank you, Prithvi ma'am, and thank you all the college members, participants, everyone. Okay, so thank you, sir. Ma'am,
Thanks a
Prithvi
lot.
ma'am, over to you.
I think Prithvi may be a little busy because I think this time she has another engagement or meeting. That's okay. I'll close the session. So, all of you, thank you so much for coming up, showing up. Even at the end of this, there are 83 people watching. That's kind of very positive. I want you people to attend all 5 days. I'll tell you why. First day is me. I triggered a little bit, so now you're a little on the path. Tomorrow, Mayuk will come and explain reinforcement learning. Third day, Praveen is going to come and explain how LLMs actually work. So that's where you get the insider knowledge of ChatGPTs and stuff. Fourth day, Mr. Dr. Manoj from Wollongong University, Dubai, he's going to explain what happens. LLMs are working in your computer, right? How do you make a small drone intelligent? Because LLMs are huge. Can you put that big a model on a drone which has memory constraints? What kind of architectural changes will take place? Now we're talking robotics and building an automated world. Fifth day, Vinay is going to come and show you how quickly you can envision a system and how quickly you can use LLMs as agents and build an entire pipeline and flow to quickly get your solutions. He's going to introduce you to builder thinking. Once you become a builder thinking, and you can trace your steps back to me where it's hardcore mathematics, right? So we are going this way so they can go back and forth, and that's how we created this webinar, the international series. Anyway, so that was great. I hope you found what you were looking for. It's never easy to sort of build a material. I didn't want to build slides. I just wanted to engage and discuss. Hopefully, this 1.5 hours really did something for you. And take it, carry forward the next day, enjoy, read math, think, be a genuinely curious learner. That's what I would say. Thank you so much.
Thank you, sir. Thank you so much. Thank you, all participants. Thank you.
Thanks a lot. Thanks a lot.
Thank you, sir.
Thank you. Thank you, sir. Thanks. So many thanks, so many bye-byes and so many claps and everything. So thankful, so humble. I'm humbled by all this. Thank you so much. All right. So with your permission, I will close this one. Thank you, Prabhuji. Thank you. Thank you, Nishchalji. Thanks. Thank you. Most appreciated. Thank you. All right. Bye-bye. Have a great day. Bye-bye.